Hello, this is Angela Robinson, coming to you from Durham Technical Community College, here to talk about some key features in your Introduction to Programming Logic and Design course. In this video, I will be talking about the basic components of programs, variables, input and output, and comparisons. Let's start with variables. A variable is a space reserved by the program on the computer to hold information you will need to accomplish the tasks. Variables are like a storage box that we use to store our Christmas decorations in. For 10 or 11 months out of the year, we keep our decorations stored away until the holiday season comes around. Then, we go and retrieve the box and use the objects that are in it to decorate our house. That is what a program does with information. It stores it in a variable until it needs it again. The kind of information a variable holds depends on the data type you assign to variables. The variable can be letters, numbers, a combination of the two, which are called a sequence of characters, or objects. When you use words or a sequence of characters, the data type is commonly known as a string. In this class, when using numbers, you will most likely use the data type real. However, many languages use numbers with many data types. Most commonly, they are either integers, which are whole numbers, or doubles, which are fractional numbers. Objects are a little bit more complex, and you will learn more about them in depth if you go on to be a programmer who uses an object-oriented programming language like Java or C#. Remember the algorithm that I put together for how to brush your teeth? There are 4 variables in this algorithm. Can you find them? They are the toothbrush, the toothpaste, the sink, and the rinsing cup. Everything else are just tasks to do. You can name a variable anything you want, but there are a few rules you need to remember so that the program you design can be written in any programming language. The first rule is they have to be one word. It cannot include spaces, and they have to be descriptive enough so that the programmers working on your program knows what it is. Secondly, you don't use punctuation. Most languages don't allow punctuation in variable names. There are special characters that are used sometimes, like the underscore, but that depends on the language that you're using. Most special characters are used for other purposes within a programming language. So, to be sure you don't infringe on those purposes, it's best not to use them. Third, it must start with a letter. Most languages only allow variables that start with a letter. And when working with object-oriented programming, it is common to start with a lowercase letter and not an uppercase letter. The uppercase letter means something different. Each variable name for toothbrush, toothpaste, and sink can be just those words. However, how would you make the words rinsing cup a variable name? You can shorten it by naming it cup. You could connect the 2 words with an underscore, shown in the second bullet, or you could just push them together like they are in the third bullet. Notice how I capitalized the word cup in that last one? I did that to easily show where the first word ends and the second begins. It also helps for readability. This is called camel case. The last 2 are the most common ways of conjoining multiple words into one word. Variables can be holding something when the program initially runs, but sometimes you don't know what the exact information is going to be. But you do know what kind of data type it's going to be, like a number or a string. You can set variables up so that they will have the space available to hold the information a user puts into the computer. This brings us to input. Input, in its simplest terms, is when the program asks the user for some information. The program prompts the user to enter something. Once the user types in the information and saves it, the program puts it into a variable. Usually a variable that the programmer has already set up to go ahead and reserve the computer space, even though it doesn't have the information to put in that space yet. In our brushing teeth example, there's a prompt to ask for your name in modules Find Toothbrush and Find Rinsing Cup. Here are some pictures of the Raptor input symbol when it is empty, with a prompt, and what it looks like when the program is running. Output is anything the program shows the user, whether it be plain text, what is being held in variables, the combo of the previous 2, or something graphical like a picture or a user interface. Here, I show the empty output symbol for Raptor at the top. On the left is the full flowchart of a program asking for your name. The first symbol is an input of what I showed you in the previous slides. The second symbol is the output concatenating the literal string hello, including the space at the end, to the variable called name. To the right is the actual output of that symbol. Notice how my name, Angela, shows and not the word name. This is a good example showing how programs use the information that variables hold. Throughout the programs that you design, you will need to compare things against each other. To compare the items you need to look at, you create a Boolean expression. Boolean expressions are logic questions that result in one of two answers, true or false. You can create these logic questions by comparing two items with relational operators. Here is a list of the relational operators that are commonly used in Boolean expressions. Let's take a look at an example from our brushing teeth program. If you live with your family or roommates and you pick up a toothbrush, you might ask yourself, is this my toothbrush? With an answer of either yes or no. In our module Find Toothbrush, we evaluate the name to see which toothbrush we use. Here I have a picture of the if statement, also known as the decision symbol in Raptor. Now that you have the basics, we can move on to more complex fundamentals. But before we do that, let's review what we have learned about in this video. Take a minute to answer the questions on the next couple of slides. The answers will show up about 5 to 10 seconds after the question shows. If you need more time than that to come up with your answer, pause the video before the answer shows.